Okay, in the second section of the review, we are representing linear functions. So these are functions, so the question, is it a function or not, is out of the picture because it is a linear function. So the word linear means if we graph these things, they would be lines. They would all be straight, or at least a series of points in a straight path. So these can be represented various ways. We can represent them in a table format, an XY table, and we can represent them with an equation, and then we can even represent them with a graph. And then you'll see on question 9 here we have it represented with an explanation of the situation, and then they give us a graph nicely enough. So let's take a look at the example here. It says find 4 solutions to y equals negative x plus 1. And it says write the solutions as ordered pairs. And so here's their result here. As I mentioned in class, I don't really love having this column between my x and y. I like having my x's and y's right next to one another. But this is fine. They chose x's. You can pick any x's you want. My recommendation was that you pick them in a nice pattern. So they started at -1. Don't know why, but they did. They started at -1 and then they just went up by 1 each time. If you pick x's in a consistent sequence, then the y's will do something consistently as well. They may not do the same thing as the x's, but they will do something consistently. And we can see that here in the table. So they chose these. These are all going up by 1s, and that's a good idea. These continue to go up by 1s. And we can see that these are actually going down 1 each time. And it does that consistently. So that's just kind of a natural check. So you pick any x's you want, and then you get the y values by replacing the x in the equation with the x that you chose. And then just calculating it. Negative in front of a -1 makes this a +1 plus 1, and that's where that 2 came from. And then this column here is super easy. It's just the x and the y that you chose and calculated, put in an ordered pair, comma between them, parentheses. And the reason this is kind of a big deal is each one of these is a single point on the graph. So we could each pick 4 different x's, so we could each get 4 different y's, so we could each get 4 different points. But that's okay because every line has an infinite number of points. So for this particular XY table, these are the 4 solutions. But again, as I mentioned, there's an infinite number of points on any line. So let's take a look at some of the examples over here. So let's do number 3 here. I'll put my work over here. Number 3, it says find 4 solutions. So I'm going to do what they did over here. I'm going to make a little XY table. What I'm going to do differently, though, is I'm going to put my Y right next to the X. I prefer to have my x's and y's right next to one another, but it's just a personal preference thing. And I'm going to pick a sequence of x's. I can pick anything I want. If in doubt, 0, 1, 2, 3 is a pretty good choice because 0 works wonderfully. And so all I'm going to do is I'm going to take this equation, the y equals -5x, and I'm going to replace the x with 0 and see what y is. And then replace the x with 1, see what y is, and continue on. So I'm going to do my work out here to the side. So this is going to be, y is going to equal -5 times the 0 that I chose. So -5 times 0, and that is 0. And then I'm going to take -5 times the 1 that I chose right here. And -5 times 1 is -5. And then -5 times the 2. Since I picked these in a nice sequence, I should see something happening nicely here, and we actually do. -5 times 2 is -10, and you'll see that it went down 5, and so the next one should go down 5, and we'll actually see that. When we take -5 times 3, that's -15. And so here's my XY table. It has my 4 solutions, but it says write the solution as ordered pairs. So I'm going to take each of these and just write it as an ordered pair. So my 4 solutions, 0, 0. So that'd be the origin. We'd have 1, -5. we would have 2, -10, and then we would have 3, -15. And that's 4 of an infinite number of solutions for that particular linear function. So let's jump to another one. Let's pick one that is maybe not quite in the right format. When the y is equal, it's really easy to pick x's and get a y. Pick an x, get a y. So 4 and 5 are pretty darn straightforward. They're very similar to number 3. But let's take a look at number 6. Number 6, I have to do a little bit of thinking because it says that x plus y equals -1. And when I pick an x, I'm going to have to do a little bit of rearranging to figure out what the y is. But I can also pick a y and calculate an x. It doesn't really matter which one I do. So I'm going to make my xy table again, and I'm going to put my x and y right next to one another. And I'm going to pick anything I want. Technically, I can pick anything, so I'm just going to go with my 0, 1, 2, 3 again. 0, 1, 2, and 3. And so when I make x 0, this is 0 plus y has to equal -1. And so this one's pretty straightforward. 0 plus y is just a y, so y has to be that -1. And we can look at that. These two numbers do add up to -1. 0 plus -1 is -1. So the x and y always have to add up to -1. So if we make x 1, this is going to be 1 plus y equals -1. And I got to think y is going to have to be a negative number so that when I add 2 or add 1 to it, it's -1. So if we think about it, if it was -1, these two would add up to 0. So it has to be even more negative than that. Well, you can actually solve this like an equation like we did in chapter 8. You can take away 1 from both sides here. Take away 1 and you get -2. And this kind of makes sense. If you add a 1 and a -2, there's one more negative than there are positives, so it's going to add up to that -1. And you can kind of see what happened here. When I increase this by 1, look what happened to the y there. So let's take x to be 2. That's going to be 2 plus y equals -1. And again, I'm just writing this equation, replacing the x with the 2 from my table. And then I'm just going to do what I did before. I'm going to take away this 2 because I want the y by itself. So when I do that, I'm going to get -3. And you should see what's going on here. This went actually down 1. It's going more into the negative. So it's going down 1, down 1. So naturally, this is going to go down 1. So this should be -4. And you can visually check that this is true. 3 and -4. There's one more negative than there is a positive, so if I add these two together, they will be -1. And so there's my table, and so now I'm just going to write them each as an ordered pair. So we have 0, -1, we have 1, -2, we have 2, -3, and then we have 3, -4. And again, this is 4 solutions, but there's actually an infinite number of solutions, x's and y's, that work in that equation. So this is just one of a lot. So let's pick 7 or 8. They asked me to graph it, and there's a bunch of ways to graph things. In lesson 9.5, we go over what I contend is the best way of graphing these, but we can graph things just by picking x's, getting y's, plotting points. So that's what I'm going to do on number 8. So I'm going to do number 8. It doesn't tell me to make an xy table or come up with solutions, but that's what I'm going to do. I'm just going to pick x's and get y's to give me some points to plot. Now technically I only need 2, but I'm going to do more than that. I'm going to do like 4 just like before, and so I'm going to end up with 4 x's and y's, and each one of those xy pairs will be a point on my graph. So if I pick x to be 0, I think that's a good choice. And now let's think about it. I'm going to be adding 5 to the x to get the y. So this time I'm actually going to make my x's go down 1 each time, because I'm going to be adding 5 to it. And if I make my x's go up, then my y's will be 5 bigger than that. So I don't want them to get out of hand because I'm going to have to sketch a little graph here. So I'm going to go 0 plus 5, and I hope that's not too challenging. That's going to be 5. Then we'll have -1 plus 5. And so I'm just using this equation, y equals x plus 5, and I'm replacing the x with the or the number that I chose. So -1 plus 5 is 4, and you see the y went down 1 when I made the x go down 1. And again, any x's you want to pick are great. It doesn't really matter. I happen to choose these because I didn't want to keep going up higher than 5, because then my graph would have to go up higher than 5. So then I do -2 plus 5, and that's 3. And then we have -3 plus 5, and that's 2. And you should see very clear-cut patterns. Clear pattern in the x's, so I should have a clear pattern in the y's. So each one of these is an ordered pair that I'm going to plot. So I'm going to have 0, 5, and I can plot that. So I'm going to sketch my little graph here. I'm going to make it quick and simple. So 1, 2, 3, 4, 5. So I'm going to have a point right there. That's 0, 5. And I will change colors maybe. So this is 0, 5 right here. That's that point. And now I'm just going to do -1, 4. So -1, 4. -1, 4 is going to be left 1 because it's -1, and then up 4. It's going to be a point right there. And technically that's enough to graph it. I could draw the line between those, but I'm going to continue to get these others too. In case I make a mistake, it's kind of a natural check mechanism there. -2, 3, left 2, and up 3. So left 2, up 3 is going to be right there. And then I have the last one, and again, I technically only need 2, so these are just checking. -3, 2 is left 3 and up 2, and that's right there. And so there we go. I could draw my line through those dots, and you should use a straight edge, unlike me just freehanding that. So there's number 8 worked out. The last one I'll discuss is number 9. Number 9, it says each small smoothie X, so X is representing the number of small smoothies, and they cost $1.50. And then each large smoothie, and that's represented by Y, so that's how many of the large ones we're getting is represented by Y. And then $3 a piece, so the large ones are twice as expensive. So we have an equation here, 1.5x plus 3y, $1.50 for each small plus $3 for each large equals 12. So that 12 is the total, and we see from the rest of it here, she can buy some, and it says with 12 bucks. So she has $12, and we're trying to figure out how many smalls and larges she can get for that $12. So I'll rewrite my equation here, 1.5x plus 3y equals 12. And when the x and the y are on the same side, it can sometimes be a little bit of work to pick an x, figure a y. So let's pick the sweetest, easiest x and y we can pick. The easiest number I know to multiply by 1.5 is 0. So let's try that. Let's pick x to be 0. And what that means is she would not get any of the smalls. She's going to get all of the larges. So if we think about it, if this was the only thing she was spending money on, $3 for each large, and she spends 12 bucks, that's going to be 4 larges, because 3 times 4 would be the whole $12. If x is 0, this part of it isn't going to contribute to the total at all. It's going to be 0. So let's do the exact opposite of that. What if she, instead of getting all larges, what if she goes with all smalls? And so if you make this one 0, if you make y 0, 3 times 0, 0. So 1.5 times x has to equal 12. And if I write that out, I could think maybe a little bit logically about it. If I could get 4 larges that are $3 a piece, if I instead get smalls that are half the price, I should be able to get twice as many of them. And when you divide by 1.5, you are going to get twice 4. You're going to get 8. So 1.5, if you went ahead and solved that, you're going to get the 8, and 8 times $1.50 is the full 12. So this is 2 solutions, and they asked me to find 2. So I could have these 2, so she could get 0 smalls and 4 larges. Or she could get 8 smalls and no larges. There are some other solutions, but on this particular situation, since the number of small and the number of large has to be positive whole numbers, a lot of the points on the line are eliminated. Like I can't make x to be 1, because if I make x 1, you're going to have a fractional number of larges, and that's not a reasonable thing. But if I make 2, if I put a 2 for x, so if I put a 2 here, $1.50 times 2 is $3. So 2 of the smalls would cost $3, leaving $9 for the rest of it. So then I could actually get y to be 3. So there's another solution I could have, but I only needed 2, and I got those 2 by picking an x to be 0. That's a super nice one. That actually on the graph would create what we are going to talk about are intercepts. So there are 2 solutions. There are others. 2, 3 is one. 4 would work out nicely because 4 smalls would be $6. And so then I could get the rest of that in larges. And then I could even do 6. I could do 6 of these. 6 times $1.50 is $9, leaving $3 to spend on $3 larges. So we could get that to work out nicely as well. If you get ones that have decimals or negatives, they would work on the line, but they wouldn't really make sense in that particular situation. So there we go. There is lesson 9 too.